recording what you're thinking as you're going, I was able to say, oh, I know what her misconception is. Her misconception is I added one over here, so I have to take one away over here to think that that's how we balance out the equation. But we need to still have, the difference still needs to remain the same distance. The distance between the two numbers has to still be the same. We can't change the distance. Because we'll either overcompensate or undercompensate. Over here, I can see her thinking too, I mean, it's fabulous. 30/70 equals 50 minus 20. Oh, but what? And then, did you compensate for both?
That's the second time we did it. The first time was more simple. I just wanted to find a different way.
Okay. But I can still see where their thinking is, okay? But you actually have to talk with the kids and walk through it, and mental math is a great place to do that. So, this takes us back to, if I get an answer, and I got an answer, so on this one, I would have said, was it accurate? Was that answer accurate? It wasn't accurate. Was it efficient? Well, sort of, right? Maybe flexibility. But I found a lot about them, because if I just looked at whether it was accurate or not, I missed the whole story. I missed the misconception that can now easily be fixed and addressed. And so next time that they do it, they're only going to compensate with one number, and it's going to be much easier for them to solve. And so now I'm going to add that flexibility, so they're going to be able to apply it in a different situation. Whereas if I just traditionally on a time test, we would mark it wrong, but we don't know why they got it wrong. What hung them up? And what happens a lot of times is we go back to stack them.
Like this?
Yep. Yeah. We go back to this.
I use my fingers.
Yep. And we start going, okay, if I have 6, can I take 9 away?
No.
Yes, you can.
Yes.
Yes, you can. What is it, Sarah? But if I have 6, can I take 9 away?
By borrowing from your neighbor.
I don't have to borrow. Well, I do.
Well, I could make, you'd have a -3.
Uh-huh. And so when we tell our kids, no, you can't do that, that's not true. Because I do it all the time on Amazon.
Yeah, I was going to say, my bank account.
My bank account, my credit card, I owe more money on my credit card than I actually have. Right? So if I have 6, I can take 9 away. But I'm in the whole 3.
It's not going to be fun.
I'm in the whole 3, right? And if I have 50, can I take 10 away?
Yeah.
What do I get?
40.
40 minus 3.
40 minus 3 gives me what?
37.
Holy moly.
Wow.
What?
Should we teach them negative numbers at this age?
Should we?
What?
I thought it was I wasn't supposed to.
That would be amazing.
I feel like I'm scared of a lot of things that are being made right now, so.
Dude, you just blew my mind. Yeah.
So did I even have to? Because this whole thing does that. This, and do they even know what this means?
Well, mine do. I drilled it, but.
But I would bank that they might know. They might know the process,
right?
But they might not know
They
why.
don't understand what they're doing.
And they might even be able to explain it. But this might not be the fastest way for them.
Right.
It might be faster to do this.
Holy wow.
I like that strategy.
I do too.
So we got to be really careful with the words that we're using, because we can't say, no, I have 6, I can't take 9 away. Yes, you can. But you still owe 3.
3.
And then I'm owing 3, so what's going to happen if I owe 3 and I have 40? Well, I have to subtract it.
Right.
Yeah.
Do you know this whole time in my life, nobody's ever done that? Ever.
Okay.
I want to do that tomorrow.
Well, and what's really, really cool with when you're doing mental math, the really fun part is when you know a more efficient strategy than what they're demonstrating, because they'll try to do that in their head. And you can't do that in your head. Or your fingers, right?
Yeah.
You can't do it. And you have to know benchmark numbers to be able to manipulate them. Okay? But what's really fun is when you say, I saw this strategy used in the classroom next door. Here's what they did. How does that work? Does it always work? Could you try it? Could you try it? I mean, so you show them, if they don't know what the next step is to get more efficient, show them one and say, does this always work? Have them form a conjecture. Oh, well, I guess if I have because we're trying to tell them that 50. Okay, if I have 6, can I take 9 away? Well, yeah, I can, guys, because it's 56. 56 is larger than 19. And even if it was reversed, if I have 19, can I take 56 away? I can, but I still owe more. You can plant.
Yeah.
You can plant to move them ahead just a little bit.
That's cool.
Okay, so we have one